Hi, this is your good friend, Professor Clary, with my good friend, old Margarine. As you know from the quiz, things haven't gone so well, and unfortunately she's been let go. But we have a great substitute for her, our good friend now, Ann Apple a Day. And Ann, of course, wants to make impression on the boss, so she says, let's do a capability study. So properly so, as the quiz says, she does an X bar and R chart. She finds the process and control. But now, step number 2 is that data normal? And of course, you're used to this by now. This is a normal distribution. And she knows that one of the assumptions of capability is that indeed your data does follow a normal distribution. So in so doing, she takes her data, puts it in Chart Runner, and takes a look at the histogram. Take a look at what you see here. First of all, let me jump to the answer. What has Chart Runner said? Chart Runner has said the particular data over here, which by visual inspection does look quite normal, indeed is normal. That is, it fits the curve, and the confidence we have in that is 95%. It also goes on to display the way in which it did that by putting down the chi-square value, which happens to be 1.4. Now, let's talk a little bit about where that came from and what that means in English. If you take a look at this particular diagram, I've really tried to make data as close to normal as I can get. The way chi-square works is it takes each cell, and like in this one, there are actually 2 actual observations in that cell. But if indeed it followed the normal distribution perfectly, how many would be in that cell? Well, it looks like about 3. That's quite close. The second one, it has 10 in it. Well, if it followed a normal distribution, that would be about the same. So in essence, chi-square is a measure of how close my actual data follows a normal distribution. Fine. What's the arithmetic of it all? Here it is right here. In your Chart Runner or your SQCPAC manual, you'll see this formula, or for that matter in any stat book. And here's what chi-square is all about. Over here, there are 2 numbers we compare. The first is the actual frequencies per cell. In other words, how many are in each cell. And secondly, the expected frequency per cell. Expected in the sense that you would expect if indeed it followed a normal distribution. I don't want to go completely through this, but on an intuitive level, I've been able to get students at least seeing the logic of this, where the way chi-square works, this obviously the sum sign says take each cell, take the actual frequency in that cell, subtract it from the expected one, and square it. Well, think about it. If indeed the actual and expected were about the same, what would that number be? Well, it would be about 0. Now we happen to divide it by FE. Let's not worry about that. But in your mind's eye, look, if indeed the actual and expected are very similar, this would be a small number. Well, what does that mean? What's a small number? Well, let's go back for a second and now see how Chart Runner works. The actual chi-square value calculated for that particular distribution was 1.4. It also tells us it's 1 degree of freedom. Now that's a combination of cell size and sample size, and again, that's in the manual. But let me just at least show you what the SQCPAC and Chart Runner does. In this particular case, it says the degrees of freedom are 1, and the tabular chi-square value is 3.84. What that means in English, if indeed I had a calculated chi-square value less than that number, what did I have? 1.84. Then I can reasonably assume my distribution is normal. If on the other hand I had a chi-square value higher than that, that assumption would not be valid. Okay, fine. Now hold on for that thought. Let me take you one place further. I got another set of data here, and I purposely made it actually not too bad. It does sort of look normal, but there are some pretty big divergent classes. Let's take a look at that one. If you take a look at that first class, the expected and actual look pretty close. The second class, there's a pretty big distance between the normal and the actual. Here it's about the same. Here it's about the same. Well, here it's vastly different, about the same, etc. The reality is, what Chart Runner shows is if this particular data set has a chi-square value of 20.98, a lot more than the first case. It goes out and clearly tells you normal distribution fails the confidence test. Again, it happens to be at 95%. If again we take a look at that chi-square value and 3 degrees of freedom, and I go back to my little table, this says if I had 3 degrees of freedom, anytime I'd have a chi-square value calculated of greater than 7.82, what does that say? It's no longer reasonable to assume it follows a normal distribution. So if I go back to this one right here, when you look at your printout, you look at that, the main thing you need to look at is whether it fails or doesn't fail that particular test. Well, there's a lot in here, but let me give you some heads up. We have a course on capability analysis, and we teach it about once a quarter. It's taught by Dr. Gordon Constable, a former colleague of mine at Rice State University, and I'm Matt Savage, head of our tech support. And it gives you a lot of experience beyond what I can do in a brief overview of this video. But we wanted to include this. This is the final one. Again, my margarine is gone, but the final one on all the different statistics that you'll find in histogram. Hopefully you enjoyed this last presentation. I'll be seeing you next month. Bye-bye.